Questions is no easy task. Exoplanets barely emit visible light of their own and orbit stars at great distances from Earth, making them extremely difficult to observe. Transits provide one of the best opportunities to study exoplanets. This is a phenomenon that occurs when a planet passes between its host star, and Earth, temporarily, reduces the apparent brightness of the star. The length of time and magnitude of the change in light intensity gives astronomers clues about the planet's size and orbit. Smaller dips in light levels just before or just after a transit can be a sign of a transiting satellite, can even reveal what the planet is made of. The small amount of light that passes through the planet's atmosphere interacts with atoms and molecules, where the light then carries information about them, which scientists can use to make inferences about conditions such as temperature, chemical composition, and formation history. However, this method has limitations. Transits only occur if a planet's orbit actually passes between its host star and Earth, meaning its orbit must be on the edge facing us. This is only true for a small fraction of planetary systems. Even when transits do occur, they are infrequent and last for a relatively short period of time, making chance observations very unlikely. Transits also tend to detect larger exoplanets that are closer to their host star. These block out more light, creating a larger dip in brightness, making detection easier. So transits cannot represent the full diversity of worlds out there. There can even be false positives. Sometimes the dip in brightness is not caused by a planet, but by another phenomenon. For example, a star passing in front of another star in a star system. Despite these limitations, the transit method has helped discover countless other worlds, thanks to the huge number of stars and planets in the universe, and the advanced technology used to find them. The Hubble Space Telescope is a major milestone in this field. Hubble has performed the first atmospheric study of Earth-sized exoplanets, captured the first image of an exoplanet in visible light, and detected the first organic molecule in the atmosphere of an exoplanet. However, these amazing discoveries have pushed Hubble to its limits to explore deeper into these worlds. This far away, we need more powerful telescopes. The James Webb Space Telescope will take this technology to the next level. The James Webb observes the universe in the infrared with unprecedented sensitivity. This is especially beneficial for studying exoplanets because the molecules in their atmospheres leave many of the most important signals in the infrared. Specifically, these wavelengths can help us find habitable planets, planets with the right conditions to maintain liquid water, emit thermal radiation that peaks in the infrared. The James Webb's sensitivity to these important wavelengths will certainly help uncover more mysteries about exoplanets and maybe even find life somewhere in the universe. It's been 3 years since NASA's James Webb Space Telescope was launched on a mission to explore the history of the universe. The James Webb embarks on a journey back to the birth of the universe. Imagine someone saying, "Let's invent a telescope that can look backwards about the Big Bang and through the depths of time to help scientists understand how planets, stars, and galaxies form, what happens when they die." It's been a fascinating journey. Here are some of the remarkable images the James Webb Telescope has captured. Music ARP 107 is a pair of colliding galaxies located 465 million light-years from Earth, in the constellation Leo Minor. This image captures a scene spanning about 400,000 light-years. The spiral galaxy is 6 times more massive than its elliptical companion. In ARP 107, 2 galaxies. In the early stages of a merger on the left, a smaller elliptical galaxy facing the larger spiral galaxy on the right, their interaction originated from an off-center collision, when the smaller galaxy hit the spiral galaxy from the side. A few 100 million years ago, these 2 bright regions are where star formation is taking place. Galaxy collisions can be triggering the birth of new stars as interstellar gas is compressed. The spiral galaxy in ARP 107 has an unusually bright core. This brightness is due in part to the supermassive black hole at the center, which is devouring surrounding matter such as gas and dust. As this matter falls into it, it heats up and releases a huge amount of energy, causing the galaxy's core to glow brightly at longer wavelengths. We can observe this bright spot of light, a clear sign of the activity of the black hole as it is sucking in matter. A fragile bridge stretches between the two galaxies, consisting of a mixture of stars and gas as a result of their interactions. This stream of matter is pulled from both galaxies as they interact, creating a visible link, emphasizing the violence of this encounter. This new image from the James Webb Space Telescope combines near-infrared and mid-infrared light. But each wavelength was also captured separately. In the mid-infrared, the galaxy's bright core stands out, while the bridge of matter connects the two galaxies. Vanishing Galaxy reveals each wavelength, offers unique perspectives on the structure of this galaxy pair. ARP 107 is striking, as it shows the dramatic effects of galactic interactions with a distorted spiral galaxy, connected by a bridge of matter to another galaxy, providing insights into the processes that drive galactic evolution. As we look across the universe, two galaxies emerge from the darkness, entwined in a gravitational dance. On the right, NGC 2207. The larger galaxy in the T-pair exerts its gravitational pull on its smaller neighbor, IC 2163 on the left. Although not yet merged, this close encounter has already begun to stretch and twist their spiral arms, creating extensions of nebulous gas streaks stretching into space, marking the early stages of this cosmic interaction. These two galaxies are located 114 million light-years from Earth. NGC 2207 has a diameter of 143,000 light-years, while galaxy IC 2163 is 10 dozen light-years, across almost the same as our own galaxy. What makes this image even more